All right, class, our next section, 8.3, day 1, showing that quadrilateral, if a quadrilateral is a parallelogram. So a parallelogram is a quadrilateral with, number 1, one pair of parallel and congruent sides. Number 2, two pairs of congruent opposite sides, or two pairs of congruent opposite angles. 3, diagonals that bisect each other, and 4, opposite sides that are parallel. So looking at ways we can prove quadrilateral is a parallelogram. In the previous section, we were looking at, we already know that they're a parallelogram, so what information can we pull from that? This is showing that it is a parallelogram. So first there's the definition, show that both pairs of opposite sides are parallel. Number 2 is show both pairs of opposite sides are congruent. That's theorem 8.7. 3 is show both pairs of opposite sides are congruent. Angles. Show both pairs of opposite angles are congruent. That's 8.8. And then show one pair of opposite sides are congruent and parallel. That's 8.9. And then show diagonals bisect each other. That's 8.10. So identifying these parallelograms, or if they're parallelograms, explain how we know that quadrilateral QRST is a parallelogram. So if we look at a parallelogram QRST over here at A, we see that we have 3 angles listed, but we don't have a 4th. So how can we know, or how can we find out what that 4th angle is, and therefore show that it is a parallelogram? Remember, for it to be a parallelogram, both pairs of opposite angles need to be congruent. So we already have 113 and 113. Those are opposite angles, and they're congruent. We just need to make sure that angle S is 67. There's a couple ways that we can find this out. One, we know that every 4-sided figure, all interior angles will add up to 360. And we can find that from our polygon interior angle sum theorem, where it was like n minus 2 times 180 will tell you how many degrees that sided figure needs to be. And if we do that with a 4-sided figure, we get 360. So 113 plus 113 plus 67 plus angle S will give us 360 degrees. And also, if it is a parallelogram, then our consecutive angles will also have to be supplementary, so they'll have to add up to 180. But we need to check this with all of them adding up to 360. So if I do 113 plus 113 plus 67 plus angle S equal 360, what will S be? And then we can check with the consecutive angles. So we get 113, 113 is 226. 226 plus 67 is 293. We subtract that from 360. I know that angle S will equal 67. So it does equal 67. So they are congruent. Q and S are congruent. So we've got 2 sets of opposite angles. So both pairs, this is our reason, both pairs of opposite angles are congruent. All right, if I look at B, how can I show that B is a parallelogram? I got 3x and 3x for some segments there, 5x and 5x. Well, if I look at QS, the whole line there, and it's broken up into two. We've got 3x here at QP, and PS is also 3x. Those are congruent segments. I know that P is the midpoint of QS. And then if I look at RT, I see that 5x and 5x are congruent. So TP and PR are congruent. So I know that my diagonals bisect one another. Each of them cuts the other in half. So diagonals bisect each other would be my reason for B. Diagonals bisect each other. All right, which theorem or reason can be used to show that the quadrilateral is a parallelogram? So, a couple ways to look at this. I'm just going to answer with the theorem numbers like 8.7, 8.8, 8.9, 8.10 as my reason, but we can give a word reason as well here also. So which reason for number one? Well, if I look at number one, 6 and 6, those are both congruent. 9 and 9 are both congruent. So my theorem that shows that my diagonals bisect one another is 8.10. So I would say 8.10, and my word reason could be diagonals bisect. Number two, which theorem states that if we've got two pairs of opposite sides that are congruent? We've got one pair on top and bottom, those are congruent, and then the ones on the right and the left are both 26, so those are congruent. The theorem that states that both pairs of opposite sides are congruent is 8.7. So I would say opposite sides are congruent. If I look at number three, I've got some congruent angles here. So we've got those angles are marked congruent, and then 71 and 71 are each congruent. And those are opposite. So my opposite angles are congruent, and that is theorem 8.8. So it would be opposite angles are congruent. And then looking at number 4, which theorem states that if you have one set of opposite parallel sides that are also congruent, that it is a parallelogram. So when our parallel and our sides are on the same side, they are congruent, and that is 8.9. So one pair of opposite sides are congruent and parallel. Congruent and parallel, and that well, looks like 11 is just the symbol for parallel. right, using algebra with parallelograms. For what value of x is quadrilateral FGHJ a parallelogram? So we need to figure out what the value of x needs to be for this to be a parallelogram. We know it's a quadrilateral, there's 4 sides. That's what quadrilateral means. But is it a parallelogram? Well, we want to make it be a parallelogram by putting in a certain number for x.
James, please copy that.
So for that to be a parallelogram, we need 5x plus 2 and 4 times x plus 2 to be congruent. So we need to make these congruent so we can use 8.9 like we did up here to have them be, or to have it be a parallelogram. So I will say 5x plus 2 equals 4 times x plus 2. And then I'll solve for x. And whatever x is will be the value x needs to be for this to be a parallelogram. So I'll need to distribute my 4. I'll have 4x plus 8 on one side, 5x plus 2 still on the other, and then work to get x by itself. So I'll subtract 4x on both sides, get rid of it on the right, subtract 2 on both sides, move the 2 over. It gives me x equals 6. Our last example down here. For what value of x is quadrilateral DFGH a parallelogram? So it looks like we're looking at the diagonals. So if you look at your reason or your ways to prove a quadrilateral is parallel or a parallelogram, the one that uses the diagonals, 8.10, we want to show the diagonals bisect each other. So already on FH, we see that it's split up into 2 congruent segments. So we need to find the value of x that makes those 2 segments congruent. So we'll set them up equal to each other because they need to be congruent. So 4x minus 7 equals 2x. We want to get x by itself, so I can subtract 2x from 4x. Add the 7 to the other side. So I get 2x equals 7, divide by 2. So x equals 3.5. Seven divided by 2. All right, that's it on the 8.3 day 1 notes. Make sure you do your homework.